In these video notes, we are going to use our properties of our parallelograms, trapezoids, and kites to determine which type of parallelogram we have, but we are also going to be looking at the slopes and if we have perpendicular lines instead of just parallel lines. So how do we determine if two lines are perpendicular to each other? So one of the first ways we did before was if we have opposite reciprocals of each other. For example, if we had 3/2 as one of them, then the other slope would be a -2/3. Another way you can think of two lines that are perpendicular is if you multiply the two slopes together, they should equal -1. For example, if we had our 3/2 and we multiplied it by -2/3, that would give us a -6/6, which then reduces down to a -1. So that would just show you that the two slopes that you multiplied together, that they are perpendicular to each other. So on number 2, now we are going to prove that the quadrilateral DEFG is a rectangle. So not only can we say it's parallel, or that the opposite sides are parallel to each other, but we also need to show that in the corners, that where they intersect, that our slopes create perpendicular lines. So we need to first show that we have two pairs of opposite sides that are parallel, and then we need to check that the corners create perpendicular angles. For the first side of slope of DE, you can see that I have 4 and 6. The rise then is 4, the run is 6, and it is negative because it's going downhill, so that slope is -2/3. The side opposite of that also has a rise of 4 and a run of 6, and it is negative. So we do have a pair of opposite sides that are parallel so far. Next, we need to make sure that the other set of opposite sides are also parallel. So for side EF down here, I have the rise is 3, the run is 2, and that is positive. The opposite side then is GD, and the rise is 3, the run is 2. So we have two pairs of opposite sides are parallel. So this tells us that quadrilateral DEFG is a parallelogram, but now to prove that it is a rectangle, we need to make sure that when we multiply the two slopes together, so one from each side, so 2/3 times a 3/2, we need to make sure that they actually equal a -1. And they do, so that shows you that all four angles are going to be perpendicular since we have pairing up the slopes will be the same. So the same thing is going to happen on these two questions. We need to classify the quadrilateral by the equations that are given to see if we have a parallelogram or if we have a rectangle, so we have perpendicular slopes or sides. So we need to find the equations of all four of these lines. So in this first one, when we solve for y by dividing everything by 4, we end up with a slope of 3/4. In this next one, I want you to tell me what is your equation in slope-intercept form, and then what is your slope for Kent Lane. When you solved it, you should get 3y equals -4x plus 9, divide everything by 3, so you would get a -4/3 x plus 3. Your slope then should be -4/3. If we do the same thing for the remaining two lines, here on Connaught Road, we divide everything by 4, so we'd get y equals 3/4 x minus 13/4 does not divide, so I'm just going to leave it like that. My slope then would be a positive 3/4. For Miller Lane on the far right, we would divide everything by 3, and this would give us a -4/3 x minus 16/3, because again, that does not divide evenly, and our slope would be a -4/3. Now remember, we are looking for any sides that are parallel, and we have one set of sides here and two sets of sides. So right now we do have a parallelogram. Next, we need to check to see if the slopes are perpendicular to each other. So we need to multiply one of each of them. So 3/4 need to be multiplied by -4/3. And we can see that we get a -12/12, so it does equal -1. So we've got 4 right angles. That means that this is a rectangle. And our reason is because we have two pairs of opposite sides are parallel, so that means it's a parallelogram, and then because of the 4 right angles, that means it is a rectangle. Now, I would like you to go ahead and find out what the slopes are of all 4 of these. So in order, so Larson, Cortez, Mason, Madison, and then Jackson Road. So find the slopes of all four of those lines. The slope of the first one, once you solve it for y, is a positive 2. The second one, then when you solve it for y, you get a negative 2. When you solve the third one for y, we subtract the 5 over, so just be careful on this one. So we get y equals 2x minus 5, so our slope is a positive 2. For the very last one, when you subtract your 2x over, you get a negative 2x minus 5, so our slope is a negative 2. Now if you notice, we have 2 that are negative 2, 2 that are positive 2, so we do have two parallel lines. Next, to see if it is a rectangle, we need to take one of each of the slopes and multiply it together to see if we get a negative 1, and we do not. So this does not equal negative 1, so there's no right angles. So if there's no right angles, then our answer is that it is a parallelogram. For number 5 is going to be very similar to what we did on the rectangle question earlier. On number 2, we need to see if this quadrilateral, if these four coordinates, gives us a parallelogram, a rectangle, rhombus, or neither. Now, realize that one thing extra that we will need to do is we need to check the slopes of the diagonals and multiply those together to see if we have perpendicular diagonals to each other, and that would tell us if it's a rhombus. But we are only going to do that if it's already a parallelogram. So for number 5, we need to pair up all the slopes of all four sides. Now realize in this one thing that makes it different is we do not have the graph done for us. So we need to use our slope formula and just make sure that you subtract your x's and y's in the same order with your two coordinates. So when we are using the slope of a and b coordinates, we're going to take our 0 minus the 2, and then for the x's, we need to take the same order, so negative 3 minus 1. This gives us a negative 2 on top and a negative 4 on the bottom. This reduces down to a positive 1/2 for our slope. So next, going on to b and c, we would have 2 minus 0, and then 1 minus 2. That gives us a 2, and then a negative 1, so just be a negative 2 overall. Next one I want you to do now is your CD, so find the slope of side CD. You should be taking 0 minus a negative 2, which becomes plus. Then on the bottom you have 2 minus a negative 2, which also becomes plus. So you've got 2 over 4, so overall you've got a positive 1/2. For the last one, for D and A, to connect our rectangle or parallelogram back together, we have 0, so I'm doing A and then my D. So A, and then 0, negative 2, negative 3, and then my negative 2. So notice you've got a couple negatives in there, so you have a positive 2 over a negative 1, which reduces down to negative 2. So far, we know that it is a parallelogram because we have two pairs of opposite sides that are parallel. So next, we need to check what are the diagonals, what are the slopes of the diagonals, to see if we need to see if it is a rhombus, and we also need to check to see if the slopes, when we multiply them together, if we have right angles in the corners. So let's go ahead and do that first, the rectangle. So if I take 1/2 and I multiply it by the negative 2 over 1, that gives us a negative 2 over 2, which gives us a negative 1. This tells us that our shape is a rectangle. We still need to check to see if it's a rhombus, because if we know it's a rhombus and it is also a rectangle, then we know that it will be a square. So for our rhombus, we need to find the diagonals of our AC and BD. So the slope of AC, we need to use 0 minus 0 on top, and then that would be a negative 3 minus a 2. So we get a 0 over negative 5, so our slope is 0, which is okay, that could happen. The slope of BD then, we have 2 minus negative 2, so it becomes a plus, and then on the bottom we have 1 minus a negative 2, which becomes plus. We have 4 over 3, and then that is our slope. So if you notice, these two are not perpendicular to each other, which tells us this is not a rhombus. So if it's not a rhombus, it is a parallelogram and it is a rectangle, then the most specific shape that we are going to say it is a rectangle. On to number 6, if we need to determine which statement is always, sometimes never, or never true, it's similar to what we've done before. This time we have the slopes of two consecutive sides of a rectangle. So think a rectangle. We know that there's right angles in there, that they need to be right angles. That consecutive sides would be like this one would be 2/3, and the one right next to it then would be our 3/2. So is that possible for those to be 3/2 and 2/3 for it's a rectangle? Now remember that these slopes need to be perpendicular to each other for it to be a rectangle. And we can check this by multiplying them together. So if we take the 2/3 times the 3/2 and see if they equal each other, or if they equal -1. In this case, it equals a 1, not a -1. So they're not right angles. So if it's not going to be a rectangle, this would be never true for our final answer. Now for number 7, to create a rectangle from our 3 given equations, we are missing one of them. And what I want you to find is a possible equation for the 4th line. So what you have to think of is we need to know that the lines are perpendicular to each other for it to be a rectangle. To compare our 3 lines that we have so far, we need to first solve for y so that we can look at what the slopes are. Once we know what the slopes are, we can then compare them and see which slope we are missing, because we need 2 pairs of opposite sides that are parallel to each other. So if we already have 2, then we need to make another one that will pair up with the missing one. And all the slopes need to be perpendicular to each other. So if we check our slopes, they should multiply to equal -1. So on for this first one. To solve for y, we would subtract our 2x over, so we would get a -2x plus 6. Our slope then would be a -2/1. For our pink one, or the second line, we would add the x to the other side, so we'd have a positive x minus 10, divide everything by 2, so we would get a positive 1/2 x minus 5, so our slope in this one would be a positive 1/2. So far we've got 2 that are different. In the last one, we need to subtract our 4x over, and then we would divide everything by 2 for the y, so we'd get a -2x minus 18, and our slope in this one is a -2/1. So if you notice, we do have one set of sides that are parallel to each other. This tells us that we need another side that is parallel to this one in pink. One thing we do want to check before we find that line is we want to take one of each of the slopes, so -2/1 and our 1/2, and make sure that we actually have right angles. And it looks like we do. So they are right angles, or perpendicular to each other, which is good. So now we just need to make up any line we want that is parallel to this other one. So we know it has to be 1/2 x, and this other number could be any other number that you want to make. So I'm going to choose that it's going to be a +8. So this is one possible line that is parallel to the other one, and that would give us 2 pairs of opposite sides that would make a rectangle because they are right angles as well.